This is the write-up video to Integrity's March XSS challenge by Bruno Modificato. If you haven't solved this challenge yet, then go to this URL to find it and to solve it. But this is the write-up video, so let's get into the write-up. As always, we have our main page here where we can find all the rules and information that you need to solve this challenge. However, we're going to skip past that right now and we're going to go straight to the challenge page here. And this is the challenge page. We can send a save message and we shouldn't forget to hash it. And it asks us for a plain text and a hashing algorithm. So let's enter something here. For example, I love integrity. And then the hashing algorithm, let's use MD5. And if we submit that, we see that the message has been sent to our server. The plain text is I love integrity and the save text is the hash of that plain text. Now immediately what I notice here is that our plain text is reflected onto this page. We see it immediately on the page again, which obviously could mean that we can get an injection there or an XSS. So let's try that out. Let's go for a payload in our plain text. So I'm going to go with an image with a source, obviously. Our source is going to be non-existent, so that's going to trigger an on error here, and our on error is going to be an alert of document.domain. All right, let's send that, and if I submit that, we see that our plain text is indeed that image, so our image worked. We have an HTML injection of some sort going on here. But we see that we did not get an alert, and that is an issue. So let's find out why we did not get that alert, and I'm going to do that by inspecting the page here so we can look at what is going on here. And in the debugging window here, we can see the page's HTML, what it's showing, and in this H1, we can find the plain text, which is our image with the source X, which doesn't exist, and then the on error, but we see that the value for this on error attribute is alert not allowed character, document.domain not allowed character. And that's kind of odd. It seems that there is some sort of firewall or filter going on here that is blocking our XSS from working because it's removing these parentheses here. And if we look on the page, the rest of the page actually shows that, because below this GIF here, we see the text, I added an additional filter to avoid XSS. So an extra filter was added here. And if you look at the screenshot below that, we see that the filter is detailed there, starting with a variable string A that's being created, and that contains a string. But if we look at that string, it's clear that that is some regex. And if we look into that regex, we see it starts with a group, and this group is going to pretty much match a single character that's present in that group. And the characters that are present here is an opening parenthesis, a backtick, and a closing parenthesis. So, okay, those characters are in our regex. Where is that regex used? Well, in the next line, we're creating a variable, and it's doing a preg replace, which is pretty much going to use regex to replace values in a string. And this takes 3 arguments in this case. The first is our regex, what it's going to look for in the string. And the string it's going to try to find that regex in is our payload, the 3rd argument in this case. So it's going to look for the regex in our payload, and if it finds that, it is going to replace the match with not allowed character, the string not allowed character, which is what we saw in this case. So the first thing we seem to need to do here is to bypass that filter. How are we going to bypass that filter? Well, one thing we could try is to Google XSS without parentheses, and well, we find a GitHub that contains a bunch of payloads where you have no parentheses in them. And I know for sure that some of these will work. So you could try a bunch of those. However, today I want to cover something slightly different, and I want to talk about HTML entities, because these are a great way of bypassing that filter. Now, what is an HTML entity? Well, it's a piece of text, so a string that begins with an ampersand and ends with a semicolon, and these are used to display characters that are otherwise very difficult to display, and they are interpreted as HTML code. So what does that mean? We have a character, but we also have a different representation of that character. Now, if the backend is not properly designed, then it will not know about that different representation, and using that, we can bypass the filter. These entities are very commonly used for example, the less than or greater than sign to prevent XSS, and that's because those in specific are reserved characters. Okay, these entities seem to be a cool thing to try out, so on this page there's also a full list of these entities, which we can find here. And let's try one of these out. So in this table, you see the representation here and then what it will be visually on the right. So let's try this ASCR as a character and see what that turns out to. So I'm just going to type an ampersand, ASCR, and then a semicolon, and let's submit that. And we see that, okay, that character gets returned as it gets shown as the character that we expect. It gets parsed and shown. That is great. Now, can we use that same principle to try and bypass this filter that blocks our parentheses? Well, let's find out. I'm going to search for a parenthesis here, and we see it over here, which is called lpar. So we can use lpar. That's the entity name, so we can use that. So here we have one of these. So let's use ampersand lpar semicolon. Now at the end, we also want to block the right-facing parenthesis, so let's use ampersand rpar semicolon. And if I submit that, well, we see it still doesn't work. That's a bummer. Let's go into the inspector again, and let's take a look at what is happening here. And this time, we see that our image actually has the correct on error. This was not blocked by the filter, because these parentheses are still present. But something else must be blocking it here. What is that? What is going on? Well, a look at the console might help us, because this second error here says it refused to execute an inline event handler because it violates the following content security policy directive. So okay, a content security policy, a CSP, is blocking us here. That's a bummer. Well, we can get around that. Let's start to find out what the CSP is and where it's coming from and how we can potentially bypass it. In the network tab, we can just reload the page and look at this request. And this request has some headers. The response headers are what's interesting to us here, because the server responds with these headers. And we can see that a content security policy is being set here. We have a default source being none, we have a style source with a nonce, and we have a script source with a nonce as well. And just from looking at that, that already looks pretty secure. But just to be sure, let's copy this and put it into a CSP evaluator. For example, Google has made this great CSP evaluator. So I've pasted that in and I've checked the CSP. And it seems that the default source is fine, the style source is fine, the script source is also decent, image source is fine. The base URI is missing, and Google sees that as a high severity finding, and there are potential exploits that you could use here to exploit a missing base URI. However, I've tried a bunch of those out, and none of them really resulted in anything here, so that might be a rabbit hole here. But what Google pretty much tells us here is that the CSP is pretty secure, and that's not what you want to hear at this point, because we are gonna have to bypass the CSP in some kind of way. But how are we going to do that? Well, the CSP in this case seems to be quite strong, and I can't figure out a way to go through it to find a way to bypass it. What if we don't deal with the CSP and we just go all the way around it? Is that possible? Well, for that, we might have to think of how this CSP appears on the page. How does the browser know that that is the CSP? That can happen in two ways. For example, first of all, it can be added in the head of the HTML code that the server sends across to us. That's where the CSP could be, or it could be in a header, in a response header on the page. In this case, we have seen that that is in a response header, so we know that. Now we also know that this web page is running PHP, so PHP is being executed here. But how did the CSP end up in our header? Well, that also has a couple of ways of happening. First of all, the web server might decide to add the CSP to every single request it sends. That is possible, and I mean, we can check that by, for example, looking at this request here. And if I go to the network tab and I reload it here, does this also have a CSP? Well, no. In this case, the request to love sender does not have a CSP. However, on the love receiver, it does. So that means that it's probably not a web server running here that is adding the CSP to every page, but in PHP, you have the header function. And the header function, well, you can use it to supply a header to be outputted with your HTML code that you're sending across to the client. And that is probably being used here. That's one of the only options that I really have left. And there's some interesting things to that, because if you look at the documentation for this header function, then you will see something interesting. And that is that in the documentation it says, remember that header must be called before any actual output is sent. So okay, the documentation says, well, you need to call the header function before any output is being sent, and that's something that can easily be forgotten. But why is that important? What is the result of that? And to understand all of that, you need to know a bit more about PHP internals, and I'm going to quickly go through it here, not in a lot of depth, but if you want that depth, definitely go and research this a bit further yourself. But in PHP, there is something called output buffering. This means that PHP has an internal buffer where it stores all of the outputs that should be sent across to the client. And this buffer has a certain size. So if PHP starts running and you echo out something, or you have some HTML there that should be sent to the client, it will add that to this buffer. But this buffer, it can fill up. And when it's filled up, it will send the request or send the response to the client and then start filling up the next buffer with more content. If our header function is called after we've already filled up a buffer, well, then it's not attached to that response. So we're sending a response to the client and without that header, without the CSP. But that only happens in a specific scenario like seen in this code sample, where we have obviously our content and then we have our header. And that's something that doesn't really happen a lot, but I mean, it could happen here, so let's just try it out. As my plain text, I am going to add our image again, and then I'm going to say MD5. Now we know that this is being outputted on the screen and we want to fill up an output buffer. So what if we just make this really, really long, like add a ton of these? I'm just going to copy them and put a ton of them in there so that we definitely fill up that buffer. And let's just try submitting that. And if we submit that, we see we have a ton of images here, a ton of content, but nothing happened. We didn't get our XSS, and that's because the CSP is still present, which we can also see if we go into the console. We see that, well, the CSP blocked these images from executing over 900 times. And that gets us stuck again. We know that this could be a potential vulnerability, but it's very unlikely because no developer would actually make that mistake. However, the PHP manual has some interesting comments here. It says, it is a very common error to read code with an include or a require function before header is being called. And now that could pose a new thing, because it's very feasible that this server here would, for example, use an include the code that is going to do the hashing in this case. It will include that, perform all of those actions in a different place, store it somewhere, and then send it across later. That is something that is perhaps more feasible. And in that case, well, the header would be called after that. But obviously in that include, in using that, we're not really getting any output from that. Unless we could potentially get some output from that. And this is something that I guess everybody found in a very quick way. If we supply a hashing algorithm that's non-existent, such as this should not exist, if I submit that, then now we see that we get an error here saying this should not exist, a warning. Now, if our hashing of our plain text here is done before we are actually going to send the header across, then that could pose an issue, because this warning occurs before the header is being sent along, and we could overflow that buffer, send it across without the header being attached to it. And let's try that out. Let's instead of having a long text in our plain text, let's go for a long text in our hashing algorithm. So I'm just gonna copy and paste this string a bunch of times across. Okay, and now if I submit this, then we see that we do get an XSS in this case, which is amazing, obviously. And we see that we have a bunch of warning messages here. So what we thought would work has actually, or seems to have worked. And if we take a look at this request here, we see that in the response, we indeed do not have this header, the CSP header. So by filling up the output buffer, we were able to bypass that CSP header. Now you might say that the challenge is resolved now. However, obviously this is a self-XSS. You're not going to be able to tell your victim, hey, just input this incredibly long string and a specific HTML tag and that will hack you. That's not something that would really work a lot. So we need to find a way of attacking a victim with this, kind of weaponizing this self-XSS and making it work for a victim. We want to make the victim make a request to this page, but that request has to be a post request. So that's a bit tough, but I've set up something here, a script here. So it starts off with a script tag. We have a submit function that is just going to submit a form, and we have that form below here. Then we have a button where if it says click me, you get free money, I don't know, anything like that, then it will submit this form, and this form will have 3 inputs, a token, a first text, and a hashing, and all of these are hidden. So the idea here is that we could get a victim to go on a random page, and on a web page, you shouldn't be scared to click a button. You shouldn't be scared of getting hacked when you click a button, so people feel comfortable clicking a random button. Now all we have to do is fill up these inputs with values, obviously. So I can do that. I have the request here in Firefox in this case. I can get the token, for example, and put that in there. And you might say, okay, well, the token that will change probably, but when I just resend these requests, I notice that the token works multiple times fine. So we can just reuse this token. I guess there must be an issue there with the way that the server is validating the tokens, that it's not, that a token can be used multiple times. Okay, token done. Then we need our first text, which is our payload in this case. So I can just copy that over. And then we need our hashing, which is our very, very long string here that I want to be able to capture here and send across as well. So yeah, as you can see, that's a lot, but we can just go back up here. And now we have all of this, and we want to obviously try this out. So what I did is I have a server running here. So just a quick localhost Python server. You could also upload this to the internet to have it accessible from anywhere. But that's good. We can try to execute that. So I'm just going to go to here. And here we have the button, click me, you get free money. I will click that button. And now we see that we end up on this page. That's good. But we didn't get an alert. And that's an issue. So let's see why we didn't get anything in a console that the CSP blocked it. So there seems to be no CSP here. But if I go over and look at our payload and what happened to it, then we can see here that this alert not allowed character document. So this not allowed character is back in here somehow, the filter that we bypassed earlier. And these pluses here are messing things up. So there's some cleaning up that we need to do. So first of all, we need to remove all of these pluses from our payloads. That's fine. And now we need to do something about this ampersand rpar and the ampersand lpar, because these are being rendered on our first page, on our page that we're hosting, and that means that they're already being converted into a parenthesis there, which means that our bypass doesn't work. So we need to encode these in some way, and a perfect way to do this is with HTML encoding. So if we copy this and we just Google HTML entity encoder decoder and we just encode this once more, then we can paste it in here, and now we can try that out once more over here. So if I just go back to my hex screen, I will reload this to be sure that we have the newest version. And if I click it now, then we see that we get our pop-up and that we have a success. So that is good. We have something that works on Firefox, but let's play around with it on Chrome as well. So in a new Chrome window, let's go here and paste it in, click our button, and now we get the tokens not set. Send at least one request from the GUI. What? Why is that happening now? I thought we had figured this one out. Well, there's one more step that we need to get through here. Let's see how we solve that. What is the reason why this is failing? Well, very often it comes down to cookies. And in this case, if we go to the love sender, which the error message told us to do, we should go to the love sender. And if I send this request, then we will see that a new cookie is being set. So a response cookie is the PHP session ID. And if that is set, then it will work. But okay, let's now go to the storage of this cookie and see if there's any protection set on this cookie. So we can look at the cookie here and we see that same site is set to none. And same site is a kind of protection on cookies where if it's same site is enabled, then these cookies won't be accessible when making post requests from cross sites, so from other domains, such as we're doing right here from localhost to this challenge domain at integrity.io. And that won't be allowed. But in this case, same site is set to none, so that shouldn't be blocking us. And well, yes, it shouldn't be, but modern browsers didn't think that was enough protection. So what did they do? Well, modern browsers such as Chrome, for example, they will, after 2 minutes of a cookie being set without this same site attribute, they will set it. So for the first 2 minutes of that cookie being set, it will be none. And then after 2 minutes, it will automatically change to lax in this case. So the browser will do that. And that's what's causing our exploit not to work. But what does that mean? Well, that's nothing that we can get around because this cookie is being set in an insecure state. So what we just have to do is we have to make our exploit visit this love sender page so it gets the cookie, so our victim gets the cookie, and then wait a second and then make our post request so that it then can perform the post request successfully because then the cookie is set. So I hope all of that is clear. Definitely check out the same site attribute in documentation and stuff, and you will learn a lot more about it there. But I've updated or exploited a little bit here. I've pretty much just added one function here, and that's the exploit function. What is this going to do? Well, if we click our button, it's going to be run. And it's then going to create a new tab. So it's going to open up a window, which is going to open a window to our challenge, to the love sender part of our challenge. And afterwards, it's also going to set a timeout for the submit function. And it's going to wait 5 seconds and then run the submit function, which, as you know, will submit our form. So it's going to first visit the love sender and then submit the form. So let's see that in action. So I'm just going to open a new Chrome here. I'm going to go in guest mode. So no page has ever been visited here. And now if I go to HTTP localhost on port 8000, I had it at hacked.html. We have our button here. I will click it for some free money. As we can see, well, first it opens up a new tab to the love sender. That's all cool. But then 5 seconds later, it redirects here, or it sends the form here to the love receiver, and our love receiver gives us our pop-up here. So we have pretty much a link that we could send to a victim, which is our hacked page here. They would click the button and then get hacked 5 seconds later. And that is how you solved this challenge. This was a crazy challenge. I enjoyed it so much. I myself learned a lot of new things here. I had, for example, not heard of this PHP output buffering. And I think a lot of people actually solved the challenge without fully understanding what happened there. But that's great. Now, this video was hopefully very useful for you to learn a couple of new things. We learned about the CSP, we learned about a PHP internal feature. We also learned about same-site cookies, and these are all things that you will definitely want to research a bit more on your own to really fully grasp and understand them. But that was it for this month's XSS challenge. As always, if you liked the video, then leave a like. If you never want to miss a challenge like these in the future, then be sure to subscribe on YouTube and follow us on Twitter so you don't miss them whilst they are running. But that is it for today's video. I hope you enjoyed it, and I hope to see you back in the next one.